Okay, so we're going to get started. I think the projector should come online there in just a second. There we go. You got two handouts today. The first one is your next assignment, which is assignment 202. We're going to be building a physical topographic model. There's kind of two parts to the assignment. Ultimately, these are examples, and I'll pass these guys around, of what you'll be making. And you'll be turning these in to me. In terms of due dates, there are two specific due dates for this assignment. The first one is the digital file that you have to turn in. That's the one that you post. That'll be due on Wednesday, March 20th. The good news for that is that we have the next two class times where we're basically creating that file. So frequently, by the time people are done with exercise 213, they're basically done with the file. The second part is that you're going to actually cut out and construct one of these models. These are due on Wednesday, April 10th. So you've got quite a gap in there. Part of the reason you have the gap is that spring break happens right in there. And I thought it would be extraordinarily cruel for me to have it due on Monday after spring break. So I did not do that. It's due on Wednesday after spring break. So you have some time to recover from your spring break hangover or whatever and build your model and turn it in. So that's why there's the big gap. It just happens to be the way that spring break falls. So when we create this today, I'm going to walk you through how we're going to be creating it. The final size of this is 11 by 17. That's what we're going to be making. It should end up being 11 by 17. You're going to be selecting your own piece of topo for this. We're going to walk through it just like we did last class, where we'll pick a piece of topo from SketchUp and we'll work all the way through. Depending on the piece of topo, your models are going to look different, and that's okay. It's to be expected. Pick something that you're interested in. The steeper the terrain gets, this one's a little bit steeper, the harder the model starts to become to build. If you pick something that's really steep, which I have seen students do, the steps become so narrow that it's really difficult to glue them together. So this is pretty boring. This is kind of cool. Somewhere in the middle of these is probably a reasonable choice. So I would go a little more complicated than this. You know, if you're feeling adventurous, this one's pretty good in terms of complexity and hill steepness and that sort of thing. So here, I'll pass a few of these guys around so you guys can start seeing it. This one's pretty plain too. So here. And we'll throw this one around too, so you get a sense. I'm going to keep one of them up here so I can use it as my talking demonstration point. OK, so when we start to create this, and that's where we're going to work on exercise 212 today, we're going to get started kind of creating these steps, etc. Like I said last class in 211, I'm going to end up repeating myself. So what I said today will overlap with what I said last class. What I say next class will overlap with what I say today. And part of that is the redundancy of really hoping that you guys get to feel comfortable with it. So I'm going to go ahead and start by opening up SketchUp so that I can get that piece of terrain to begin with. Under template, I'm going to use the architectural design feet and inches template. And there we go. The only thing that I'm going to do in SketchUp is select the person and press the delete key because I don't need the person. And then I'll go to the File menu and I'll go to Geolocation, Add Location. And this is where we're picking the location. Last time I did something in Mount Diablo. Let's go to Tahoe, just for the fun of it. Yeah.
Is this something new from last class? We don't need the file from last class?
You don't need to work with the file from last class. If you want to use the file from last class, you can, but it's not required that you use the file from last class. So let's see here. Maybe I'll take this piece. Remember that the maximum region that you can grab is the rectangle in SketchUp. As you zoom in, the rectangle gets bigger, and ultimately you can grab the whole thing. So let's say I select the region. I'm going to take the maximum amount. There it is. I'll go ahead and grab it. Once it comes in, it's always a good idea to go to the File menu and then go to Geolocation and go Show Terrain, because you can get a sense for, is it too steep, is it not steep enough, etc. So okay, so that one seems reasonable. I'll go ahead and save this one. I'll go to File and then Save As. And remember, to be able to bring it into SketchUp, we need to go back. Version 7 for sure will come in. I think version 2013 will come in as well. And I will save this on my flash drive here. And there we go. So that one's saved. I'll go ahead at this point and open up Rhino. Maybe. There we go. My template will be large object inches. I want to make sure that I'm in inches because as I bring in the SketchUp file, it's going to be coming in as inches. So it's important to make sure that those two are the same. I'll go to the File menu, and I'll choose Import. So I'm not inserting this as a block instance. I'm actually importing it directly into my file. Let me go to my folder here. There was Tahoe. Default SketchUp import options are just fine. We'll go ahead and say OK to those. And there we go. They come in. If I want to see this a little bit easier, I'll switch into shaded mode. So we can see there's my mesh, and there is the flat image that SketchUp tends to bring in. I'm going to organize my layers just a bit. I'm going to do a layer for SketchUp. And I'll do a sublayer under SketchUp for terrain. And a sublayer here for the surface. Let me change the object layer here. We'll turn that one off. And this one, I will change this so that it's on there. That gives me control over just my SketchUp objects. I'm going to delete the rest of these objects. They don't matter. There we go. They're all done. And it's time to start working with this piece of terrain. So just like last class, and so far everything that I've done repeated what happened last class, though I did go a little faster today than I did last class. Just like last class, we want to take this mesh and we want to make a NURBS smooth surface out of it. So we're going to repeat the same process with the contours in the X and the contours in the Y to go through this. So I'm going to go ahead and give myself a new layer. We'll call this Contour X. And I'll go ahead and give one more new layer called Contour Y. There we go. So I have Contour X and Contour Y. It's time to actually divide this up. So I'll double click on Contour X to make that the current layer. And then we'll go ahead and slice it up. I'm going to go to the Edit menu. I'm going to go to, I'm going to go to the Curve from Objects, Contour. Alternatively, I could actually just type Contour. It's going to ask me to select the objects for my contours. That would be my mesh file right here. I'll press Enter to continue. Contour base point. I don't have any object snaps turned on just yet, so let me turn on my object snaps. And end, mid, and perpendicular are what I typically have on, but it still won't snap. So I'm going to come down here to vertex, and that's going to let me snap to the surface. So right there on the corner. And I'm going to go off in the X or Y direction, depending. It doesn't really matter. But I want to make sure that I'm not snapping to anything. I'm actually going straight off in that direction. There it is. Distance between the contours, I did it at 100 feet last time. That's probably about right this time. So I'll type 100 feet, followed by the Enter key. And it should slice up my surface. If I did it correctly, all of those lines in the right view here should be perfectly up and down, which they are. That's good. Perfectly vertical. I'm going to repeat the process, this time on the Contour Y layer. I'll double click on Contour Y. I'll make sure that nothing is selected so that I don't end up contouring the lines and getting points. And then I'll go back to my Curve from Objects, Contour. Select Objects for Contours. there's my mesh again. I'll press enter. I'll start right down here at that point again, and I'm going to go off. And I'm not getting my axes, so I'm going to turn ortho on to make sure I'm on my axes. There it is. I'll click off here in space. Distance between the contours is the same amount, 100 feet. And now I end up with that set of contours. At this point, I can turn off the SketchUp layers altogether, and I have just a network of curves to start to establish this surface. So I have those. I need to trim off the ends so that they're nice and even. So I'll take maybe that curve, that curve, that curve, and that curve. Oops. How about that curve? There we go. And I'll use the top view, and I'll type trim. Or I could go up to edit and then trim. And I'm going to select all those lines that are off on the edges here that are going to give me the ragged edges. There we go. So I've trimmed off all of those edges. I'll hit enter when I'm done. Gives me a nice square, and it also has no ragged edges around the outside of it. Time to build that into its actual surface. But remember, this is the point where Rhino could end up crashing, so it's a good point to save. So I'm going to go up to File and then Save. And we'll put this into my folder for today. And this is spring of 2019. There we go. Perfect. So now it's time to actually create the surface out of this. But before I do that, I want to create a new layer for that surface to go on. So I'll create a brand new layer, and we'll call this layer Terrain. I'll make sure that it's the current layer, so I'll double click on it. And then it's time to do the curve network. So it's under Surface, Curve Network, or I could type in Network Surface, Network SRF. Select curves in the network. Should be all of those curves right there. I'll press enter, and I get the, are you sure you want to do it with so many curves? Yes, I do. If I did it correctly, I should get A, B, C, and D on my 4 sides. And I'll go ahead and say OK. This takes a little bit of time, so we need to be patient here while it builds it out.
How do you change the distance of
The what? It'll ask when you start to create the contour. It'll say distance between contours. So hang tight for a little bit while this works. I'll pause it and start again. OK, so when it's done, it's going to show up black like this. Remember, this is when Rhino really slows down because the complexity of this surface is just too high. So we're going to rebuild the surface. So I'm going to select the surface by clicking on it. It's going to turn solid yellow like that. And I will type in rebuild, or I'll go to the edit menu and choose rebuild. Either way. And I'm going to rebuild that at a minimum of 200 by 200. My guess is that a rebuild of 100 by 100 is about the right level of smoothing. Remember, we talked a lot about that last class. I'll start with 200 by 200 just to take a look. There it is. I'll turn off contours X and Y, so I'm down to just the surface here. Actually, in this sense, it's not too bad. There's still a little bit on that ridge there. Let me go ahead and rebuild again, and we'll do it maybe at 100 by 100. Yeah, that feels a little bit better in terms of the smoothing. So, just like last class, we got to the point where I have a nice NURBS surface, nice smooth surface, that I want to start building into one of these models. So essentially, everything that I did so far is just repetition of what we did last class, which is why I had you do it last class, so you'd be ready to concentrate on what we're going to do today. So when it comes to actually building the physical model, we need a couple pieces of information. Number one, we need to know how big this physical model is actually going to be. That's important. And in order to know how big that physical model is going to be, we need to know what scale we're going to build the model in. If you're in a studio class, let's say you're in 220 or 221 or something like that, and you're trying to build a site model, sometimes the instructor will give you, you need to do a site model at 1/16 of an inch equals a foot, or at 1 to 200, or some scale. Well, in that case, they've given you that information. For us, we just have a piece of terrain. I don't know how big we want to make it. We just need to make sure that whatever scale we choose fits on this piece of terrain. So on the course website and on your handout, I have this little chart. This is a chart that I made that will help you sort out how big certain things are at different scales. I have it open in Photoshop so I can use a little highlighter so we can kind of point things out of what's happening. So first thing here is going down this side, we have our drawing scale. So you've got 1 to 500, 1 to 250, 1 to 200, etc. Then we get into the actual architectural scale. So like here is 1/8 of an inch equals a foot. And so depending on the size of your piece of terrain, this is going to vary. We have a giant piece of terrain, so we're probably going to be working somewhere in the neighborhood of 1 to 200, 1 to 250, something like that, because it's really big. So if I was going to work at, let's say, 1 to 200 scale, for example, so if I picked this as my scale, I would come over here to where it says paper size. This is 11 by 17. And I'd come down here and I'd say, OK, that means that my model would be 2,200 feet by 3,400 feet. So let's take a look at how big that rectangle would be on my Rhino file. So let me go into my top view for a second. And sometimes it helps to show this in shaded mode so you can kind of see what's happening. And I will draw a rectangle that is at 2,200 feet, 3,400 feet. Notice it's in feet. I'll go ahead and press enter. That then is 11 by 17 inches at 1 to 200 scale. Could you come up with the math yourself? Absolutely. I'm just trying to help you out a little bit. So that seems like it fits rather nicely. I'm going to trim off parts of my terrain. Some of the other scales would probably fit. The one above, the 1 to 250, at 2750 by 4250 would probably work as well. So I could do at 2750 by 4250. Okay, at 2750 feet by 4250 feet. And that one would probably fit as well. The 1 to 500 probably won't fit in terms of size. So I could pick either one. I could do either one. It doesn't really matter for our purposes. And like I said, that would be something that was probably given to you. But in this scenario, it's not given to you. You just pick one that you like and one that fits. So next piece of this is I need to think about what part of the terrain do I want to build my model of. So over here in my terrain, for example, it's a little on the boring side. Over here, if I were to move this over here, OK, that's a little bit more interesting. I've got some hills. You know, maybe there it includes the top of that mountain. OK, that looks kind of interesting. I think maybe I'll pick that piece. Yeah, that'll work. So the next part of this is I need to have this rectangle projected down onto the surface itself so I can get rid of and trim off the rest of the terrain that I don't need. And so I have my rectangle. It's the right size. I'm going to switch over into the top view. I'm going to use my project command. So it'll be curve from objects, project. Or I could type in project. Select curves and points to project. There's my curve. I'll press enter. Select surfaces. There's my surface. I'll press enter. And so what that did, and remember it is in the top view, is it took my rectangle and it projected it so that it's on the surface, like that. At this point, I can use that curve to trim off the rest of the surface. So I'll go to Edit and then Trim. I'll trim off the rest of the surface, and I'm left with just this little piece of terrain that is exactly the scale of an 11 by 17 model. So that's what I'm going to end up creating this model of, right there. And it's at the right scale. So a couple quick notes. Make sure you don't, sorry, wrong one. Make sure you don't pick the laser bed size, pick the 11 by 17 size. So you need to be in this column when you're creating your rectangle. Okay, so now I have this. It's time to start thinking of this as a model. And so I need to establish the steps that are the thickness of the cardboard. So last time when we contoured in the Z, I said, oh, do it at 40 feet. Well, this time we need to know the thickness of the physical modeling material in order to determine what the contour interval should be. So the thickness of the material is the important part. So you would go to the store, you'd buy your material, you'd measure very carefully the thickness of that material. So this is the cardboard that's out of the bookstore. It's the one that they sell. That's what I'm going to recommend that you guys use to build this. I think it costs like $3 or $4 per sheet. You'll need 2 sheets to build it. So it's, you know, an $8 project. It's not too expensive. I think you guys can afford that, even if you have to give up Starbucks for a day. So we need to know the thickness of this material. So the good news is I'm not going to make you go buy it and then measure it. I happen to know what the thickness is. It's very close to being 1/8 of an inch, but by the time you put a little glue in there and if you measure carefully enough, it's more like 5/32. So it's a little bit more than 1/8 of an inch. So you want to be precise when you do this measurement. So I'm going to go back to that handy dandy little chart that I had, and I'm going to look over here at the contour material thickness. So this is in inches. It's 5/32 of an inch. So I'm going to find out where the 5/32 intersects with the desired scale. So I'll come over here. It's right there, 31.25 feet. So right here, 31.25 feet is the distance in between the contours in the Z direction. If you used a different scale, so if I used 1 to 250, for example, it would be 39.063 feet. If I came down here and I was modeling at 1/8 scale, it would be, oh, well, yeah, it would be 1 foot contour intervals, because it would be, or that was at 8. Sorry. 1.25 feet. Anyway, you get the idea. So 31.25 is my magic number. And so I'm going to come back to my surface, and I'm going to create a new layer. And this is, you could call it contour Z if you wanted. I'll double click to make contour Z active. There it is. I'm going to contour that surface. So I'll go back up to my curve from objects, contour, or I could type in contour. I'm going to select my objects for contour. There it is. I'll press enter. Contour base point, I'll pick a low corner, say right there. Now I don't want to go in the X, I don't want to go in the Y, I want to go in the Z. I may have to switch my view over into the front or right side view so that I can for sure be going straight up and down. There it is, going straight up and down. I will click, and now I need to type in my distance. So this is where that 31.25, this number, comes into play. So I'll come back over here into Rhino. It should be 31.25. Again, it's in feet, so I have to make sure I put that foot mark in. And I'll go ahead and press enter. And that then slices up my piece of terrain at the intervals that are the thickness of the cardboard that I'm going to build the 3D model from. So it's important to recognize why I picked that number, because it's from the cardboard itself. So at this point, I'll go ahead and turn off the terrain. It leaves me with just the contours in the Z direction. And you can imagine and you can start to see where these contours look an awful lot like this model. That's where we're going. But now take a look for a second at the sides of this model. So in order to support all of this contour, we need to build the side with the little steps at the contour intervals. And so this is the last piece of what we're building today, and then you'll continue working on it next class. So the goal here would be to get to this step today. And that is that we have to actually draw out all of these little steps going up and down the sides. And I'll show you how this process works as we move forward. So there are two different methods that I'm going to show you in terms of how you would do this. To me, one of them is significantly easier long term, but it's a little harder to get your head around it initially. The other one is easier in the short term, but it will be annoying long term. So I'll start with the easier short term solution, and that is to create a series of points. I'm going to come over here. Let me actually create a layer first, and I'll call this step 1. We'll make that active, and I'll create a series of points right here. Notice that if I left click, it's a single point. If I right click on the button, it's multiple points. So you'll want to right click. And I will create a point on the end of every one of these lines. So I work my way up to that side. I'll work my way down this side. Oops. And there we go. When I'm done, I'll press enter. I accidentally created an extra point that I didn't need. So I have points at the end of all of those contours. I want to select all of those points. I can drag a box through them like this. Make sure that you don't select any of the curves, like that. And with all of those points selected, I'm going to rotate them 3D so that they're flat. So I'll go up to my transform. I'll go to rotate 3D. I'll start at this point. I'll go straight off along the X or Y axis, whatever it is. I'll go straight up, and I'll fold all of those lines flat. Once I have those lines folded flat, I can start to draw my steps. So I'll come over to the polyline tool. I'll start at the first point. I'm essentially drawing a straight line until I meet that point. Let me turn on my point snap so that I can snap to that point. I'll come over to perpendicular, and there it is. I'll come to the next one, snap to perpendicular. There we go. Snap to perpendicular. And I'm starting to draw all of these points. Okay, so now here, those 2 points are in a line. It happens to be the top of a hill, so it's going to start going down. So I'm just going to go straight across and then start my way back down the other side. So I'm using smart tracking to get all those snap lines correct. And there we go. I finished it. When I'm done with all of those steps, I'll select them and the points. I'll do another rotate 3D. So I'll go back to transform and then rotate 3D. Start at the same point and fold this back up to where it's along the edge. And we can kind of confirm that, yeah, that looks the way it should. So that's one method. With the points, you fold it flat and you draw. The other method is going to introduce a concept called a C-plane, or a drawing plane. It's kind of like the UCS coordinates in AutoCAD, if you're familiar with those. And that is that instead of drawing, so like right now, if I were to draw, everything that I draw is going to be flat on the ground. So it's always going to be flat. Instead of drawing in that context, I want to draw so that it's vertical. I want to choose what plane I'm drawing in. And so to do that, I'm going to go to the little triangle next to where it says perspective here. I'm going to go to set C-plane, and I'm going to choose 3 points to set the C-plane. And like I said, this is a little harder to understand initially, but if you can grasp this as a concept, it'll save you a bunch of time later on. So my C-plane origin, I'm going to do this side this time. I'm going to pick this point, this end point right there. And when I do it, you see that I get a little set of axes that are there. I want to go straight off along this direction. And I need to go straight up. So I'll change my view into the front view. And when I do that, and it goes straight up, I see a little mini grid that represents the plane in which I'm drawing. Sometimes people like to see more of the grid so that they understand the plane a little bit better. We can make that grid a little bit larger. Just so that you can see it a little bit better. That is now the plane that I'm drawing in. So with that plane selected, that's all I need to start drawing the steps. I can go right to the lines and I can start drawing right along the side of all of these steps. Those two come straight across. This one goes back down. This is at the bottom of a little valley. So I've gone down here. I need to go down, straight over, and back up. I know what my distance is, though. It's 31.25 feet down, over, and then we'll go back up. That's at the top, so we go straight across. And we work our way back down here. .25 feet down, over, back to there, over, and then we've got a few more little steps to go. And we finish. Don't worry about the corners. We're going to come back and do the corners next class. And if you make a mistake on these where it's at a top or a bottom, we're going to go back and review all of those tops and bottoms next class. Yeah?
So you put the triangle, C-plane, and then the origin?
3 points. So when you're done, I'm going to do it again right now. When you're done, you need to go back to reset the C-plane to be normal. If you ever feel like the C-plane got off or something's funky and it's not working the way you want, reset the C-plane to normal. And you're going to do that, hold on one second, by going to Set C-plane World Top, this one. And it resets everything to the defaults. So it's Set C-plane World Top. Question?
So you can only have one active at a time?
You can only have one active C-plane at a time. So, and it is active only in one view. So the C-plane in the top view is different than the C-plane in the perspective view, is different than the C-plane in the right view, is different than the C-plane in the front view. So we can change it for any one of these, but it will only change for that one. So one more time, if I was going to do it on the end here, I would go up to this triangle, I would go to Set C-plane, and this would be 3 points right here. I'd start it right here. First direction would be going off in space this way. Again, I'm not snapping to anything. You don't. The last thing you want to do is go off like say that, and then like that, because then see how your C-plane is on an angle? That's a bad thing. So we'll go back to set it to world top. That resets the whole thing. Then we'll go back to set C-plane 3 points. We'll start at that first point. I'm not snapping to anything. I'm just going right along the axes. And then we'll go straight up and down. And there it is. And then we can go ahead and draw these points. Come on. Sometimes it doesn't do what you want them to do. I don't know, something's going on with those 2 points. I'll have to come back and figure out what's going on. Maybe I'm not reading it correctly. Anyway, you guys get the idea where you're working through those points and you're getting your steps. When I'm done, I would go back again to set C-plane, world top. That resets everything, and then move on. Don't try to go from one angled C-plane to another. So never go to set, after you have your C-plane set, don't go back and say set with 3 points again. It's way too complicated. Always go back to top C-plane first and then reset it to one of the sides. So my goal for you today is to get to the point where you're here, where you have all the sides drawn, no matter which method you use. Ignore the corners. We'll come back for the corners next class, and then save your work. You'll post a JPEG, a screen capture of this. So once it's set, you'll go up here to the triangle. You go to capture to file. That'll save a JPEG of your work. That's what you'll post for today. Next class, you'll continue working on this same model. You'll also learn real quickly today if it's too steep, because your steps will get too close on one side, in which case you might want to pick a simpler piece of terrain. Okay? Are there any questions? No? Okay, I'll turn you guys loose to work on this. Again, I'll do a bunch of repetition next class. Question for everybody or just you? Okay, I'll come over there in just a second.